Hello and welcome. Welcome to the webinar Unified Solution for the Entire Analytics Lifecycle, a webinar about more or less technical dive into IBM Cloud Pak for data. My name is Vedran Podupski. I work in Megatrend as a business solutions consultant, mainly with a focus on mainly an implementation specialist for various BI solutions and also DBA. So joining me here today also is Mr. Arcadius from IBM, and I will let him now do also a short introduction of himself.
Hello, everybody. Good afternoon. My name is Arek Wiśniewski, and working for IBM, I'm responsible for so-called information architecture. And this is like 90% of data and AI software portfolio, including also Cloud Pak for data. And today I'm here to assist Vedran in the webinar. Respond maybe to some of your questions or inquiries, or maybe supplement some Vedran statements. So thank you for your participation, and I do hope that you will have a very nice hour with us. So right now, going on mute.
Okay, thank you, Arcadius. So, okay, we can start. So for today, our agenda for this webinar will be as this which you see. So we will talk shortly about a general overview. What is Cloud Pak for data? Then we will see a bit more of the technical overview of the inner workings directly in the Cloud Pak for data. So we will discuss a bit on the type of the technologies used in, you can say, under the hood of the Cloud Pak for data, explain a bit a theory on which the Cloud Pak for data is developed on, you can say. Then we will discuss about the term of ledger to AI. Then we will explain the workflow used in Cloud Pak for data, so which is called collect, organize, analyze, and infuse. We will do a brief explanation of the use cases and the value of Cloud Pak for data, or CPD for short, and then we will explain a bit also the use cases or the best values afterwards. Why to use Cloud Pak for data and cartridges. This then we will also do a short overview of the user interface in Cloud Pak for data, and we will see the available services and tools directly in the tool, in the system itself, how it looks when you are logged into it. And then afterwards, after everything, we will do a little pause where you can also ask your questions or whatever. Feel free to ask the questions in the Q&A section here in Zoom. Meanwhile, while the presentation is going on. So, and then we will, after the presentation is finished, we will take some time to answer your questions if you would have any. So let's start. So what is IBM Cloud? What it is? IBM Cloud Data. So Cloud for Data is a fully integrated platform, data and AI platform, which is used to modernize the way how businesses collect, organize, and analyze the data, and to infuse artificial intelligence throughout all of their working processes in the process when working with data. So it uses an agile approach to the complete concept, and it's it can be used from data management, DataOps, data governance, business analytics. It can create it has automated AI procedures inside, and it helps to eliminate a lot of costs in day-to-day work in every, you could say, business, and it can be used in any business and by various job roles or people inside the company, from data scientists, business users, data engineers, data stewards, application developers, and other roles, for everybody who needs to work anything with the data. So end-to-end data and analytics workflows. So the complete process of working in Cloud Pak for Data is created from the pure collection of the data, connection to the data, and access to the data. Then that data can be governed, searched through, so we can discover new data. And then after we create an understanding to the data, we can prepare it for the analysis, with the usage of popular open source frameworks, and so we can prepare the data to be structured or unstructured data. We can prepare it to be ready for something, for a pure analysis like this. Using the built-in AI services, we can create machine learning, deep learning, optimization of our data, create advanced mathematical models. We can also design our data models programmatically or visually, with also various tooling and IBM frameworks, and afterwards create dashboards and reports as they are. So then we can then afterwards we can manage our models which we created, so prescriptive models, reports. We can manage them and move them across development stage, testing, staging area, and deploy to production. So, and with the tools provided inside Cloud Pak for Data, we can also automate those functions in an agile way. So we can also create a way of continuous development with or DevOps. So in this case, DataOps, so we can continuously deploy our products and speed up our, you can say, time to market directly, and enhance our work with data and discovery of data, reporting, and else. So we can basically, with Cloud Pak for Data, we can manage our all of our data, enable our governance, data governance, secure access, regardless of the location of the data, regardless where the data itself lives. We can build our ladder to AI, so we can infuse our complete process with advanced artificial intelligence, and with that we can modernize our complete data and analytic workloads, and shift from monolithic system to more efficient microservices system. And also create our data to be compliance ready with GDPR and other laws, you could say, and the regulatory compliances which we need. So to explain a bit the history behind the complete digital transformation process, we can see here this image, which describes the methods of software, you could say, development, deployment on a various and environments on where the software can be deployed. So this is you could say some history overview. So in the 80s we had deployment processes used as a waterfall. Then we switched around around 2010 around 2000s we switched to agile programming as is, and the most modern process now is the DevOps, or you can say these are the sets of processes which are created, which are used for continuous integration of softwares in software industry. So the development was during the 80s, you can say, or the basis of initial development was monolithic, which were created, you could say, as a standalone applications, which needed their own servers, and everybody was working on that servers. Then we switched to the entire development system, which is a client server type of development, which was then modernized, and the latest trend, you can say, and revolution of the development process are microservices, where we split our full application, we split in little chunks, separately specialized, each for its own function, and therefore we increase scalability and also speed, because we have a small application which is directly specialized for its own function, and not a big application which does everything by itself. So, and the deployments, so the basis of the deployments were, first the software industry did the deployments on the bare metal servers, then virtual servers were created, which of course increased the better, they increased the usage of bare metal servers by with the possibility to create more virtual machines on one bare metal server. And the latest and currently most efficient way is to deploy services and applications in containers, which are in this case Docker containers, which are an economical virtualization offering, you can say, because they do not need for every application can be deployed in its own container without a need to have a separate operating system for each application, and we can do a small virtual machines without a need of separate operating systems, and host a lot of separate small specialized virtual machines on over one operating system, an example. And then the environment on which the software can be, or was and can be deployed, is directly on-premise. So this was the old system where everything was on-premise. Then we witnessed the creation of the cloud. So we could start deploying some applications, and this on cloud, and also on hybrid, you can say, environments which were partly on cloud, partly on premise, and also the completely off-premise clouds, which are, you can say, the most modern solutions. And some trends which are forming now is that more than 80% of all companies in the world will have at least 60% of their data pushed to the cloud wherever it's possible. So IBM Cloud Pak for Data, as you see here, the part of this table is highlighted. So IBM Cloud Pak for Data covers all of this, you could say, modern solutions, and it works on the basis of this all of this most modern solutions. So it can be deployed on-premise, off-premise. So it can be deployed on-premise, off-premise, and in cloud. So that's you can say a hybrid solution, and also it can be based. This is a development method of agile compliant. To develop applications in this. And what this means with microservices, we can be completely cloud native. What this means is to design and run all of the applications to take advantage of all of the benefits of the cloud system. So focusing on the horizontal design and treating the instances on every instance of the application as a separate service. So what that can be called treating the applications as cattle, not as a pet. So to be completely cloud native, applications have to have three properties. They should be container packaged, running the application and process as a isolated unit. They are dynamically managed by some central orchestration process, in example, Kubernetes or Apache Mesos. And they have to be microservices oriented. So having small focused applications to be also composable via some service endpoints as REST or something like that. So this approach helps enterprises to ship faster, to create applications much faster and increase efficiency, because the built applications are autonomous services, and they can be stopped and started with no consequences. So, in example, when you are having one application which has a lot of services in it. So in a monolithic architecture, usually if you need to restart just one service, you need to restart the complete application, and which takes, of course, time, which increases memory loads, CPU loads, IO loads, like this. And with a microservice, you can just restart a small service and keep all other parts of the application running without a risk of the long downtime, etc. So this is all can be applied on IBM Cloud for Data. So it works on a microservices, and it can run anywhere. So on-premise, hybrid solutions, and cloud, as we already mentioned. And it has so with the usage of the microservices, it has a lot of services and tools inside the complete system. So the tools in IBM Cloud Pak for Data, as we will see afterwards in the demo, you will see the categories themselves and more about the tools. But the main services and tools, so categories used in IBM Cloud Pak for Data are, an example, AI, which are the notable applications are Watson Assistant, an example for creating the chatbots, Watson machine learning, of course, used for creating machine learning models, for executing, you could say, machine learning, and Watson Studio for creating machine learning models. And it's also, we have a lot of other, you could say, IBM Watson AI modules for other specific usages. Then we have the analytics services. They have a lot of tools also, with notable to mention are Cognos Analytics, then analytics engine for Apache Spark, Data Refinery, and others. So also from version 3.0, IBM Cloud Pak for Data will include IBM Planning Analytics, as the so then we have the dashboarding. We have the dashboarding tools. So, in example, analytics dashboards service. With that, we can create our data dashboards without even without a need, you can say, to use other software, but directly create a dashboard from our data. So no need, you can say, to use some other complex BI suite or whatever. We can directly also create dashboards from our data. So then we have data governance category, which is used to in which we can mention, the example, data stage for ETL procedures, then regulatory accelerator for making the governance in data done much faster, and you can say automatic. Also, data governance can be used after creating the data governance rules. Then we have also proprietary data warehousing there, which we can use to warehouse our data in IBM Cloud, in Cloud Pak for Data, in example, or to speed up our analytics and the data discovery process or whatever. We can mention, in example, CockroachDB, IBM DB2, of course, MongoDB, PostgreSQL. Also, IBM recently included the Enterprise DB. Also, they included the Enterprise DB, so you have the high-end, you can say, Enterprise PostgreSQL as available solution. And also, of course, we need to mention the data virtualization, which is a capability which is unique to IBM Cloud Pak for Data to virtualize almost any data, create a virtual schema inside and query the data no matter where it is. So it doesn't move the data, but it creates a virtual view on the data wherever it is, on-premise, off-premise, and you can directly work on that data without a need to move it into some other data warehouse or move it to the cloud as it is. So we have also development tools, which are, in example, Jupyter notebooks with a support for GPU, and we have RStudio for developing in R. We have a Lightbend platform for reactive microservices, for developing microservices, and we also have some industry-ready solutions, which is an example for financial crimes insight, financial services workbench, etc. So, ladder to AI. What is a ladder to AI? So we know that the biggest and most complex challenges sometimes come with managing the data, because data is not self-organizing. We cannot sometimes we cannot understand the data directly, and this can be explained also with this DIKW pyramid, which shows here, which we see on the left side of the image, that we have the data. So the data is the less you can say is the least amount of perceived usefulness. So if we have our data, our information on that data has higher value than the data itself. Knowledge of that data and information has higher value, and after we have the information and knowledge in our data, then we are creating wisdom. Then we really know our data. So the AI ladder also works in a similar fashion. So it contains 4 discrete levels: collect, organize, analyze, and infuse. So what we can say about every step? So to modernize our data and to modernize our business, you can say, with the artificial intelligence and multi-cloud world, we need to follow the steps of the ladder to AI, to the artificial intelligence. The first one is collect. So we need to collect our data in some way and make it simple, accessible, and we here are incorporating data into any analytic process. So we need to collect every type of data regardless where it is, and make it simple and accessible. Then we need to organize that data to create some trusted governed analytics and exclude data of inferior quality, exclude the data which is misleading. So we can have the maximum control of our data, and also to organize our data to be discoverable, cataloged, profiled, categorized, classified, and secured after all. So we have one single source of truth in our data before we analyze it. So we do not get then we step to the next step, which is analyze. We don't want to have our analysis, of course, wrong. This is why we organize and cleanse our data. So the third step is, of course, analyze, where we can analyze our data which we cleaned, and analytics can be human-centered or machine-centered. In IBM Cloud Pak for data, we have a possibility to infuse everything with the artificial intelligence or augmented intelligence when the context is human-centered, and artificial intelligence that can help us analyze our data, find new data, determine what has happened, determine what is happening, determine what might happen, and compare against some expectations, and then automate and optimize the decisions which we are doing for our analysis. And the final step in the ladder to AI is Infuse. So here we are infusing the data and analysis which we did, or machine-based, human-based analysis which we did. We are infusing it with additional artificial intelligence, so it allows our data to be used for complete automation and optimization. Then exercising a deployed model, we can develop insights and decision making. So that's all beneficial to create a data-driven organization and to be applied by the data-centric enterprise as itself. Here we can see a bit more of the more details. You can say a bit something under the hood, you can say, of each step. So here we can see that we can use various, so starting from the bottom up, we can see that we can use almost any data source, so enterprise data, third-party clouds, sensors, weather, social media, to ingest the data or virtualize the data and just read it, you can say, with the Cloud Pak for data, to collect, then do the virtualization, federation, integration, consolidate that data in a form as we need to. Then we can move that data if we need, of course, if we do not need to use virtualization, but we can move it into some kind of a governed data lake. So get all our data underneath one umbrella or one roof, as it can be said. So we have all our data in one place. Then we can do the organization of it with the governance, catalog our data, load our metadata, so we can search it, apply our rules, policies, whatever our organization needs. And we already see here that we are overlapping with the analysis step, and we here have already a help from artificial intelligence in the organization process to discover the data, maybe discover some links between our data which we didn't even know as is. So we can prepare our data for analysis and use so here we can use Watson machine learning to create models which will, in example, browse through our data, create some microservice which will automatically create some reporting, then create our dashboards reporting with Cognos, develop, of course, our machine learning processes and learning models, and then afterwards analyze all that data and deliver to the customers in a way that we can have our data processed with a chatbot. So, in example, your customer can ask a chatbot a question, and the chatbot can extract the data from a governed data lake and give an answer to the customer directly from your data. In example, that could be a short example how this can be used. So if we now do a little more deeper dive into the process of the AI ladder. So AI ladder comes from collect, organize, analyze, and infuse. Here we can see an example, one overview of the AI ladder with the specific parts of how is something happening if we want to do a process through the AI ladder. So the first process is collect and organize. Here, if you can see the numbers, So we are starting on the bottom with the number 1. So we are collecting our data source. Then with a connector, used for data integration, we are connecting our data of some asset and metadata. So we are identifying the metadata and the types of asset, how to connect to our schema, and how the data is structured. So on the step 3, we're capturing that metadata from the process which copies the data from one location or another, or does the virtualization itself. Then we are creating a data catalog. Which provides a search interface, so we can be aware of our data landscape itself. Then we are discovering all the metadata. At step 5, we are discovering the metadata, and we are adding additional insights to our data content, and we are populating it back to the knowledge catalog. So after we create our data knowledge catalog, in the knowledge catalog we have the glossary, you can say, which defines the meaning of the terminology used by the people working in an organization, and therefore with that we can organize our data and find the relevant data with relevant glossary terms inside, so the governance teams can add the definitions of, you can say, assets which should be governed, and link them to the classifications. And this all makes our data easily searchable with you can say glossary, which every human can afterwards understand. Then after we organize the knowledge catalog, we know where our data is, then we encode the governance definitions, so the enforcement and auditing of the governance requirements is completely automated like this. Then the governance requirements, classification, asset details are then sent. So on the step 8, we are now on step 8, it are sent to an operational metadata store. So we are creating our, you can say, database. So this is a this is a functionality very similar to Hadoop and the big data system, which have, in example, separate metadata stores with which in which we are just keeping the data. So you can say the dictionary of the data of which we have, so we can easily search it and know where our data is without a need to constantly query our data directly from the source. So we are creating, you can say, a data governed dictionary, which glossary, you can say, afterwards, to always know where our data lies, what it is, and also the data is completely governed. So we are creating a governed data lake. So a large population of users can access the data catalog and search for their data relevant to their job need or whatever. So these are the steps, you can say, collect and organize. Then we are forming there, then we are switching to analysis step, where the business. So here we are coming from the top. On the top, we are coming that from the number 1. We are starting with the analysis that the business needs to define a desired outcome. which can be realized then by creating an AI model, so predictive model, which can automatically, so we are creating a data model with Watson Studio. So they are then going to the governed data lake so here you can see the number 3. We are going to the governed data lake to look for existing catalogs, which we collected in the step before, to identify the informing features and towards building up effective predictive model. So they know which data structures they have and whatever, so they can create some model to discover their data in their predictive model as is. Then some signals could be extracted out of third-party social data or whatever. So that's used in step data governance in step 4. They are developing what to virtualize, which data to virtualize, which to federate, and for their model which they are developing. Then informing, so on the step 6 we can see that we are again refining the data, but this time with the predictive model. Then if we have some of the unstructured data, in example, we are developing the unstructured data, which we pulled from the governed data lake. Afterwards, we are on the step 7, we are then applying the AI services on our model, which we created. We apply the AI services to enrich it with the natural language understanding and other visual recognition and whatever. After all those enrichments were done, we are pushing back the data again to the data lake, and we are creating, you can say, iterative in nature. We are creating a new business case, which will also be written in the data lake itself. And then we are going back to the model builder and creating, you can say, and deploying our model into machine learning environment. And this way we are creating, you can say, a completely automated model which can provide us with our data depending on the business case. And the final step is the Infuse. So Infuse is, you can say, I will not, we don't have much more time, so I will not go into much details, but the infusement of the AI in the complete work process is that our model, which we created on the in the model builder for extracting the data, for modifying the data, governing the data, whatever, can be completely machine over the machine learning deployments, and AI orchestrators can be completely automated, and with that we can deploy our solutions with the Insights Orchestrator. Also we can orchestrate, this is a decision management and optimization. These are using Insights Orchestrator, using the decision management optimization components, can also provide us with so automated solution which we can deploy to our customer with that. So the main use cases and value of IBM Cloud Pak for data can be described by, you can say, containers and container management and their efficiency. They can with containers, companies can improve their readiness for cloud, as we already discussed before on the topic of microservices. So Cloud Pak for Data is completely compliant, as we already said. Data virtualization is a unique, also as already told before. Virtual data virtualization is a unique property of IBM Cloud Pak for Data. No other competitor uses this, so we can virtualize our data and access it from anywhere, and you can, with the data virtualization and governance, you can create data sets available to any business analyst, data scientist, without any migration, no need to use ETL processes or whatever. Then afterwards, we have, of course, data science, machine learning, and artificial intelligence benefits, which can contribute to more productivity of the data scientists, because they don't need to think they do not need to think on all. They can automate their process, and artificial intelligence can automate it for them. It can recognize some links and between the data itself, etc. And of course, the main benefit also is the unified platform. So everything is under one roof, under one umbrella, you can say, and you don't need to have multiple environments regarding the when talking about IBM Cloud Pak for Data. So here we can see also use cases and their value. So we have data modernization, of course, which I've already mentioned. So we are unifying the our complete data distribution of data. We do not need multiple silos, databases, and clouds. We have everything underneath one solution. Then, yes, we have self-service to access to data, improvement of data governance and quality issues, also with AI, with automatization, also in AI. Then operationalize AI. Then we can leverage our tools to automate and give us multiple insights into our data. Then we can deploy our AI apps with we can develop innovative applications, so which I described before. So you can create your model and automatically deploy it to work in your favor on your own data. This, and yes, of course, the cloud native workloads, next gen cloud native workloads, regarding the technology of microservices, containers created on Red Hat OpenShift. You can immediately scale up, scale down without a need to turn off the application to do big restarts or whatever. You just add your application and it immediately, as a microservice, starts or restarts or stops whenever you need it. Then the use cases also of our pillars of AI are for the for collect phase, of course, the data virtualization, which you already mentioned, because it gives speed through data pipeline automation. You don't need to move your data anywhere. So you have the Watson knowledge catalog for organization, which is automated, which can automate the data access and governance as is after creating the rules. And automatically, you can also analyze the data with artificial intelligence, also by deploying models, so you can increase your revenue and cost savings with machine learning. So to sum up why to use IBM Cloud Pak for data and cartridges, I'll explain what cartridges are. So you can address all information management with the ladder to AI under one system, under one umbrella. You have completely integrated solutions with multiple tools with one administration plane, so you have just one source, one destination on which you are administering all of your services. Then you can differentiate data with virtualization, cataloging, and AI, also to better know your data. It's a truly hybrid solution, so you can deploy it anywhere on any environment, so on-premise, off-premise, so hybrid or cloud, directly cloud-based. And of course, it's suited for any type, small or big organization, so it depends of the license, so standard or enterprise. Flexible usage is also with the base platform. You already have all of the tools needed for doing the complete ladder to AI process, and also for when using CPD cartridges. So what Cloud Pak for data cartridges are sets of premium, you can say, tools. In example, data stage, in example, what's on Open Studio, DB2 or something. These are the sets of tools which with which you can also, if a company has already some IBM product on premise, in example DB2, the entitlement is valid also for cloud and for on-premise with the same number of VPCs. So you can use it on-premise and in cloud with the same license. It's dual completely. So that's approximately it. Before the demo, I will also turn my microphone to Arkadius again, who will also have some supplements or some summary of the webinar. Arkadius?
Hey, Vedran, everybody. So in fact, Vedran has summarized this, perfectly. So really little left to me. So what I would like to share with you is that Cloud Pak for data, look at this as a kind of BI and AI ERP system, modular solution, which you can, let's call it, organized in a way it's suitable for your demand. So and it's also flexible in terms of usage in on a time scale. So for example, you can start with more VPCs needed for example, DB2 warehouse, and less for Watson knowledge catalog. And then, for example, along the time, you can, for example, limit the number of VPC on one fraud on, for example, this DB2 warehouse, and then increase on Watson knowledge catalog. So it gives a lot of flexibility, but under the comprehensive umbrella of really many capabilities which we have put underneath. Well, honestly, there is no need to tell more from me on this. I would rather, Vedran, you to show the system, okay, and then carry on. So thank you, and if there will be some questions, so maybe I will jump on them.
Okay, thank you, Arkadius. Okay, we will switch now to the short overview of the UI. So I will not also bother you with much details on this, but we will see Let's see here. So here we can see this is the landing page, the main page of when you log into your IBM Cloud, you can customize your dashboard, which here you can say some governance rules which are applied, some data protection rules. So this is an overview of how many assets you have, so how many views, how many tables, files, notebooks, and deployed applications, and which assets are governed, in example, with those rules which are applied here. And on the main menu, you have of course, your home. Here you can view your projects, your connections to various data sources, assets. Then you can see your instances which are running, and then we have this collect, organize, analyze flow, which here we can see all of our data. We can see our data virtualization, the data virtualizations, which we did, so our connections to some data somewhere, which doesn't, of course, as I already said, doesn't need to be in the cloud itself. And here we have different sections for different tools which we can use on our data as they are. And here we can now see, click here, yes, okay. Now we can see here the complete set of services which we can have in Cloud Pak for Data. So we have the AI, so they are also grouped in the groups which I also mentioned before. So we have AI services, which so natural language and understanding, Watson assistance for chatbots, discovering data, this. So here we can see also what's already enabled. So this is, you can say, a base platform, doesn't have all the tools already available, but with cartridges we add additional premium. So if we have Watson cartridge, we will enable all of the premium services, in example, for AI, and also then we can use it on-premise, off-premise with the same VPC license. Like this, then we go to the category of analytics. Now we see that we have a lot of tools here. So analytics for Apache Spark, Cognos Analytics, data refinery, execution mechanism for Apache Hadoop if we have big data systems, something like that. Then analytics dashboards, which is also part of the base platform, so we can immediately do dashboards without a need, in example, to have Cognos Analytics. We can create dashboards from our data. Then we have the data stage for ETLs. Then regulatory accelerator, which will streamline our process. With machine learning, it can discover our regulatory rules inside our data. We have knowledge catalog for governance, also powered by Watson or AI, like this. Then we have our data sources, so we can create our data lakes inside of any of these databases itself. We can push our data inside. We can ingest our data into these, or already developed data with machine learning models, and this we can push into our data sources. Then we have developer tools, as I mentioned, Jupyter Notebooks for Python with for GPU, Lightband, open source management, RStudio. These are the industry-ready solutions. So for financial crisis insight, services workbench for creating microservices and machine learning, also models for financial services. Then this is the customer prospecting accelerator, which automatically also increases, unlocks real sales leads from data. It can also discover some new sale points out of our data. These are the separate storages. Storage is an example for persistent storage for containers and etc. So all of this things in Cloud Pak for Data, you can go to the link to Cloud Pak for Data demos. You can register if you have an IBM account, or register for IBM account. You can see it by yourself. You have 7 days of free Cloud Pak for Data usage, so you can use the base platform to test, in example, virtualization of data, so you can all see that yourself. You can click around, get a feel for how it is to work and how to work in Cloud Pak for Data itself. So this is, I will not bother you more with the functionality directly here. So this would be approximately it. So now if you have any questions, you can write into Q&A section. We will answer them, and if not, we will still leave a presentation still running, but that's it currently from now from me. That would be it for today. If you have any questions, write them in Q&A section. Arkadius or me will answer. If not, I will say thank you and have a nice day. We will still be here for around 5 minutes, just for if you have any questions. If not, thank you for listening. I hope it was okay for you. And that would be that from me. Thank you.